Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. My name is Muhammad Azim bin Zulkarnain, and as can you see the faces at the slide, they are my group members, which is consists of 6 of us. Today, our group will present a comparative analysis of 2 significant case studies in surface water drainage system. The first focuses on the Botakiri irrigation project, and the second one is explore the Ipoh City Council's main drainage system annual contract. This presentation is part of our coursework for Construction Technology 4 under the guidance and help of Dr. Wan Faida binti Wan Muhammad Azmi. Let us take you all through the insight and findings from these 2 case studies. So before we go through the case studies, what is surface water drainage? Surface water drainage is a cornerstone of urban and rural development. It protects the communities from flooding, soil erosion and waterlogging. Over time, evolving urbanization and climate change has increased the complexity and challenges of designing effective drainage system to ensure that the excessive water or the rainwater run smoothly and effectively. Our analysis underscores the importance of sustainable practices, innovation designs, and robust maintenance strategies. Through the lens of these 2 cases study, we aim to highlight the critical role of effective drainage system in urban resilience. Alright, we will first dive into the Botakiri project, where the primary goal was to upgrade aging irrigation system and mitigate flooding risk. Then we will examine the Ipoh City Council project, which focus on maintaining and upgrading the drainage system in a residential urban zone. Both cases provide a very valuable lessons in design, implementation and long-term maintenance of the drainage system. Okay, I will present our first case study, which is project menaik taraf sistem pengairan di rancangan pengairan Botakiri. So this project took place in Botakiri and conducted from June to December 2019. The primary goal of this initiative was to upgrade the region's drainage system to address the flooding problems, improve water quality and enhance the agriculture productivity. So let's explore the background first. The Botakiri region plays a critical role in Malaysia agriculture output, but it has faced significant challenges due to an outdated drainage system. So there are 3 issues, which is small size drains and culvert incapable of managing the stormwater during heavy falls, frequent flooding in low-lying areas, and threatening the agriculture productivity and residential safety. And the third challenges is blockages caused by insufficient maintenance and tidal factor that worsen the stormwater discharge. This project was launched to address these challenges and establish a reliable, sustainable drainage system that could support both the agriculture sector and the local community. So this project have 3 key objectives, which is flood mitigation, improve water qualities, and sustainability and resilience. So in order to achieve these 3 main objectives, there are several critical interventions were implemented. The first one is drainage infrastructure improvement. The second one is flood mitigation measure. The third one, environmental enhancement, and the fourth one, hydrological and hydraulic studies. So let us go through one by one. So the first one, existing earth drains were converted into concrete lime channels to enhance the water flow efficiency and reducing the maintenance needs. And the culverts were resized to handle larger stormwater volumes, especially during heavy rainfall. So the second intervention is flood mitigation measures. So the stormwater retention facility were installed by them to manage peak runoff effectively and to reduce the risk of flooding in surrounding areas. The third key intervention is environmental enhancements. They proposed and introduced the sustainable drainage system, or we call it as SUDS, suits, to improve the water quality and reduce the pollution in nearby water sources. And the last key intervention is hydrological and hydraulic studies. They were conducted their studies to understand the water condition in that area and easy to them to enabling tailored solution for both countries' unique challenges. And next is the project achieved several significant.
In the construction process, multiple parties collaborate to ensure project success, including architects, designers, engineers, contractors, and quantity surveyors. Each has specific responsibilities, working as a team to complete the project within the client's budget and timeline. For the drainage improvement project in Bota Kiri, Perak, August Construction, the main contractor, oversees the project's progress, addressing delays and budget issues. Key contributors include PYK Consultant as the civil and structural engineer, Perunding JW as the mechanical and electrical engineer, and Etabina and Management Sendirian Berhad as the quantity surveyor. Together, these parties aim to deliver the project efficiently and effectively.
Next, we go to main drainage channel. The location is located along the borderlines of the residential areas to collect water from the smaller U-drain. The design is larger and deeper precast concrete U-drain is used. It is supported with struts to provide additional support and stability to drain. Average depth not exceeding 2 meters. The benefits of using main drainage channel effectively channels large volumes of water, ensures stability and durability with strut support, complements smaller U-drains for comprehensive drainage. Main drainage channels ensure seamless water flow, supporting residential drainage system efficiently and reliable.
Right, next, I will cover the key materials and equipment used in the construction of drainage system. So the primary materials include precast concrete U-drains and culverts, which are essential for efficient water management. On the equipment side, we use excavator, mobile cranes, and compactor, which is play a crucial role in site preparation and installation. Together with these components, ensure the durability, functionality, efficiency of modern drainage system. So I will go to the precast concrete U-drain first. So these precast U-drains are essential components in modern drainage system. Their prefabrication allows for high durability, cost effectiveness, and precise dimension. It was manufactured off-site. This U-drain saves significant times and ensure top-notch quality. It is ideal for various terrains and scales. For example, a standard U-drain measuring 300 mm x 300 mm x 1 meter height costs around Rm65 per unit. So additionally, using materials like glulam popuyu ensure a long-term performance of the surface water drainage. And then we go on to next material, which is culvert. These culverts are vital for directing water under infrastructure like roads and railways, preventing flooding and erosion. Their flexibility designs adapt to flow rates and site condition. For instance, a standard 300 mm diameter or 1.52 length of culvert costs around Rm120 per unit. So using these precast materials enhance the durability and simplifies the installation on site, which is suitable for our case study. Next, the equipment used for this case study project. So as can you see at the slide, we have excavator, mobile cranes, and compactor. So this specialized equipment is a key to constructing drainage system efficiently. Excavators can handle the trenching and site preparation, while mobile cranes ensure the accurate placement of precast concrete components, which is minimizing the damage to the precast. And the last equipment is compactor. which is used to stabilize the ground and preventing future issues like sinking.
Next, we move to the effectiveness of system in preventing flooding and water damages. In Boti Kiri Perak, flooding and water damage are significant challenges. The project come up with two methods that effective for flood prevention measures, which is enlarged U-shaped drains and precast concrete culvert. The enlargement of U-shaped drains increases the capacity to handle heavy rainfall, reducing overflow and waterlogging. These drains are designed to resist sediment blockages and high water pressure, ensuring durability and efficiency over time. Proper sizing and slope design, guided by hydrological studies, further enhance their effectiveness. Meanwhile, precast concrete culverts complement this system by channeling water away from critical areas. These culverts are durable, low maintenance, and quick to install, with customization options to suit site-specific needs. By connecting U-shaped drains to culverts, we create a smooth and efficient flow of water, minimizing flood risk.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ismail Bemaso. So we will be continuing with the problem involved for the first project, which is a project menaik taras sistem pengairan di rancangan pengairan Bota Kiri at Perak. So for the first problem is flooding. So flooding is a critical challenge faced by surface water drainage system, often stemming from inadequate design or poor maintenance. So when drainage system fail to manage heavy rainfall effectively, so they will become overwhelmed, causing water to stagnate and flood surrounding areas. This can lead to significant disruption, including traffic congestion, property damage, and also heightened risk to public safety. So, an efficient drainage system is essential to prevent these issues and to ensure the smooth management of surface water, particularly during storms. The next challenge for surface water drainage is clogging and blockage, which also can severely affect their efficiency. Drainage systems are designed to transport water away from urban areas to prevent flooding and waterlogging. However, they are highly susceptible to obstruction from various forms of debris. Inadequate maintenance of drainage system allow materials such as scraps, rubbish, and plastic waste to accumulate, obstructing the flow of water through drainage channels. This blockage reduces the system capacity to handle heavy rainfall and increasing the risk of flooding. Other than that, sedimentation also a significant problem for the surface water drainage system, particularly in areas like these projects. Over time, sediments such as sand, silt, and organic matters accumulate within the drainage system. And then these sediments will build up, further restrict the flow of water, exacerbating the drainage efficiency and increasing the likelihood of waterlogging or flooding.
The construction team plays a vital role in designing and building project based on the client's requirements. For the Ipoh City Council main drainage system annual contract, the client is Majlis Bandar Ipoh, responsible for public infrastructure management. The main contractor is Kiss Empire Enterprise, a G2 contractor capable of handling projects up to RM500,000. Manages the project. Their subcontractor Ilam Tamilan Enterprise specialise in tasks like installing precast concrete elements and drainage repairs, while labourers handle cleaning and excavation. Coordination between all parties ensures the project success, improving drainage for public safety and well-being.
Now let me talk about location and design. Precast concrete U-drain. The location typically placed along the side of internal roads and at the perimeter of each unit residential house like backyards and communal open space. The design, the type of drain used is half precast concrete U-drain, rectangular in shape with proper gradient. The benefit is durable and cost-effective, easy to install with precast manufacturing, prevents flooding and water use case. For example, residential house developments with improved drainage and reduced maintenance issues. The closing statement, precast U-drain offer a durable, efficient, and economical solution for modern residential water management.
Assalamualaikum warahmatullahi wabarakatuh. Uh, Today I will present about the maintenance for the surface water drainage. For case study 1 and case study 2, they use the same type of the drainage, which is the U-drain. So the maintenance for the drain is the routine maintenance, ensure that U-drain systems operate efficiently by addressing the common issues that arise during regular use. So one of the primary tasks is the removal, which involves clearing accumulated trash, leaf, weed, and sediments that can obstruct the water flow of the drainage. This can be done manually for smaller drains, like the case 32, the small U drains, using the specialized vacuum or such equipment for larger system. Additionally, grates and covers should be inspected and cleaned regularly to prevent blockage and maintain their structural integrity, as damage or clogged grates can disrupt the system functionality. Entry and exit points of the drains, such as inlets and outlets, also require routine checks, so the water can flow freely without the obstructions.
Now we move to the effectiveness of system in preventing flooding and water damages for case study 2, which located at Jalan Rapat Jaya, Ipoh, Perak. Efficient and effective drainage systems are essential to prevent flooding and water damage. This project come up with two key upgrades, which is replacing damaged precast concrete U-drains and installing new reinforced concrete slabs. Damaged U-drains often block water flow, leading to stagnation and localized flooding. Replacing them with higher quality precast U-drains ensures smooth and efficient water flow, even during heavy rain. These U-drains are durable and resistant to water pressure and sediment build-up, restoring the drainage system functionality. Meanwhile, reinforced concrete slabs enhance the system further by protecting the drains from external forces like vehicle loads and debris. These slabs also improve safety by covering open drains and reducing maintenance needs. Proper installation preserve the system's structural integrity and ensuring long-term performance.
Next, we will be move on to the second project, which is a drain system at Sistem Saluran Utama Barijelis Bandaraya Ipoh, Perak. So the problem involved at this project is the maintenance issue. So maintenance is a critical challenge in surface water drainage system. Effective drainage requires routine upkeep to ensure the continuous flow of runoff, but many systems suffer from neglect due to limited resources or poor planning. So without regular cleaning and inspection, drains become blocked with debris and sediment, reducing their capacity and increasing the risk of flooding, especially during heavy fall. Due to the financial constraint and a lack of qualified personnel often contribute to maintenance issue, leading to reactive solutions that address problems only after significant damage has occurred. Next, we move on with the recommendation for the improvement that could be made to make surface water drainage system will be more effective and efficient. So I have done some research on how to improve the surface water drainage system. As you can see, I have listed 3 recommendations to make the surface water drainage system to be more effective and efficient. So for the first thing that I would like to recommend is to modernize the infrastructure. So modernizing the existing drainage infrastructure is essential to address the challenges posed by increased urbanization and climate change. This involves integrating advanced technologies such as remotely controllable automated gates and pumps to enhance water flow control during heavy rainfall. Additionally, using advanced control materials like corrosion-resistant materials and reinforced concrete can extend the lifespan of drainage system, ensuring durability even in harsh environments. This can reduce the need for frequent repairs, lower the maintenance costs, and improve overall system efficiency. The second recommendation is I would like to recommend to use the eco-friendly material. So incorporating environmentally friendly and durable materials in drainage system can enhance the longevity and reduce the environmental impact. Utilizing recycled material in construction and implementing bioorientation techniques support sustainable water management. This approach can reduce the flood risk while also enhancing urban biodiversity and increasing the amenity value of urban space. So, by integrating eco-friendly solutions, cities can achieve more resilient and sustainable drainage system that benefit both the environment and community. For the last recommendation, uh, I would like them to use the data-driven decision making. So by leveraging big data analytic and using machine learning can significantly enhance drainage system management by improving decision making processes. Data-driven method can provide real-time information on flood risk and system performance, restraining emergency response strategies. Additionally, using AI for predictive maintenance allows for forecasting component failures, facilitating timely repairs and replacement, and also can ensuring system reliability and efficiency.
Assalamualaikum warahmatullahi wabarakatuh. Introducing myself. My name is Muhammad Farhan bin Anwar, and I would like to continue on the similarity of the both project. Assalamualaikum warahmatullahi wabarakatuh. I will continue on the type of drain use. And for the similarity of this project, for the both project is using the same type of the drain. Both is using the U-shaped drain. The size overall both project is 1200 mm and ensuring the durability, efficient water flow management. Purpose: the purpose the U-shaped drain is for its effectiveness in handling large volume of water, making it suitable for both project. And as we know, for the boat project is urban and rural application. As we know, at the bottom project is consists of the paddy fields. When the rains, it need the water flow. And for the next is standard design. The design allows for easy installation, maintenance while providing consistent performance across different environments. The U-shaped drain is well known in Malaysia and well used. Is that because their durability and also easy to maintain. Number next is share benefits. By using the same type of drainage system, both projects aim to address water management challenge, flood prevention in Ipoh and water flow improvement in Botakiri. The similarity highlight the versatility and reliability of the U-shaped drains, catering to distinct needs in both urban and agriculture setting. And because that we are using that type of drain. For the next is the similarity is the project location. Both projects are situated in the state of Perak, Malaysia, highlighting the region's focus improving water management infrastructure. And for the first one is project in Ipoh, an urban area where the project focus on the flood prevention is a destination neighborhood at the Jalan Rapat Jaya, and the the water flow need to be more maintained every year. Botakiri, a rural area where the project emphasize improving the water flow for paddy fields, as I mentioned before, benefiting the local agriculture industry. And regional importance, this project reflects Perak's commitment to addressing both urban and rural water management challenge, ensuring sustainable development across the state. And shall we look at the machinery use? I think for the both on the excavation work, they are using the same type of the machinery. For the first one, both our project utilize a backhoe as a primary excavator, highlighting its versatility and efficient in drainage construction and maintenance. Because as we can see at the Botakiri project, their length of the drain is really long, and they need a versatile machinery, and also not the very big size of the machinery. Key function of the backhoe, of course, as we know, they can excavating soil for the installation of the U-shape, preparing the site for efficient drainage system for construction, and also supporting additional tasks like clearing debris, leveling the ground, also the to lift the precast U drain using the backhoe. Uh, as we know, the backhoe is very cost effective, easily accessible, and suitable for the urban project like Ipoh and rural works like Botakiri. This shared use demonstrate the adaptability of the backhoe across varying project scale and environment. Then I will continue on the differences. And for the first one is we going to talk about the purpose of the project, the difference between the both project. And the IPO project, the urban prevention project, urban flood prevention. Objective is to avoid flooding in the residential area by installing the U-shaped drainage system. The challenge addressed is urban stormwater runoff due to the intensive paving, threats of water lodging during the heavy rainfall. Impact is efficiently captures and channel the stormwater away from the residential zones, minimize disruption to urban life through the backhoe excavation, ensuring quick and precise installation into confined space. And for the next is Bota Kiri project, enhancing the agriculture water flow to improve water flow for paddy field irrigation using the U-shaped drainage system. Challenge addressed is waterlogging in paddy field during the high rainfall, inconsistent water supply for agricultural needs. The impact is enhanced soil health and maximize the crop yields, ensures minimal disruption to farming activities through precise and efficient installation using the excavation, deliver long-term benefits to the local agriculture community. Then the different continue by the size of the project. And for the first one is we look at the Ipoh project. The drainage length is 4 meter and the allocated 500,000. But not only for this project, it's allocated for the zone in Ipoh, meaning that the maintenance of the drainage system. The duration of the project in the Jalan Rapat Jaya is 3 weeks. The scope small, localized project focusing on the specific residential area. And for the next, we look at the Botakiri project. The drainage system is almost 100 meters, meaning that it's a very big project. And the budget allocated is 8,199,571 ringgit, and the duration is about the 12 weeks. A large scale of project addressing agriculture water management across the broad rural area. Then we will continue on the duration of the project. is not very different between both from the previous slide, and we shall look at the Ipoh project first. And as I mentioned before, the project in Ipoh is 3 weeks. The project is focusing not only for the reconstruction, of course, it's also for the maintenance and minor upgrades to the existing drainage system. With a smaller drainage length, just a 4 meter, the scope of work is limited and specific residential area in urban setting. And the shorter duration allow for quick execution with minimal disruption for resident daily activities, ensuring the work completed efficiently within the time frame. And the project in Ipoh, as we know, the project is only 3 weeks because it's involving in minor upgrading the drainage system there. And next is a Botakiri project. The duration is a bit long comparing to the Ipoh project. It's a 12 weeks. This is because the larger scale project requiring the construction for a new drainage system over 100 meters to improve water flow in a paddy fields. The extended timeline is necessary to handle the complex tasks involved, including excavation, drainage installation, and adjustment for agriculture water management. The longer duration ensure the proper planning and execution while minimizing disruption to ongoing farming activities, which are critical for the local community livelihoods.
Now we move to the comparison of effectiveness and efficiency of two drainage system improvement projects in Perak. The objective for both projects aim to prevent flooding and water damage by upgrading existing drainage systems. For methods and functionality, case study 1, the enlarged U-drains and precast concrete culverts increase water flow capacity and durability. For case study 2, replacement of damaged U-drains and installation of reinforced concrete slabs ensures smoother water flow and better efficiency. Next, for environmental impact, both projects align with natural waterways, reducing erosion and improving urban resilience. For long-term benefits, they enhance flood resilience, improve water flow efficiency, and ensure safety, quality of life, and drainage functionality for residents. These projects demonstrate how strategic drainage upgrades can address urban flooding challenges effectively.
Next, I will continue on the cost analysis of this both projects. And then for the cost analysis, for the first one, we shall look at the Ipoh project. It consists 500,000 ringgit, 500,000 ringgit, and located for multiplier project, not exclusive for this one, because the the project is for the zone B at the Ipoh, and is of course for the maintaining the drainage system, and not to only for the reconstruction for the damaged drainage. For this project is a very small scale, and it's not involving a lot of the material, and only for the, of course, involving on the BRC, using the BRC concrete, and then the precast U drain. For the next, focus on maintenance and minor upgrades requiring fewer materials and labor. Urban location reduce logistical expense to the better accessibility and cost efficiency, because if you compare for the both project, and Ipoh project is more lower on the cost because their size of the project, and of course the purpose of project is different if you look at, and the cost per meter of the drainage. And next, shall we look at the Botakiri project? Comparing both project is a more way bigger, because the budget is 8 million, almost 9 million, I think, because the project larger scope involved in 100-meter for the new drainage construction, significantly increasing material and labor costs. It's not just limited for the U drain. It's of course the the material, including the machinery, the labor, because the project is very big. The need for the machinery labor is way more bigger, and require additional equipment such as tractors, back pushers for the complex tasks like loading precast structures. Uh, and as I mentioned before, they are not only for the U-shaped drain, it's a round culvert also, and for the next, for the needs of that project is also included a lot of the machinery like back pusher and tractors. And for the next, rural location increase logistic challenge. Of course, if you look at the road, is very small, and the logistic could be hard because the the accessibility mobility is a bit more harder. And uh, and for the next is cost efficiency. The higher overall cost of, but the project benefits a broader area and supports the agriculture economy, providing long-term value for the local community. The key takeaway is the IPO project is more effective for the urban flood prevention in a small area, while the Boulder Kiri project justify the higher cost by addressing larger scale agriculture needs and supporting long-term economic benefits. And
Assalamualaikum warahmatullahi wabarakatuh. So today I will present a conclusion. Based on these two study cases, most of the study cases are aiming to focus on effective drainage system in cases of flooding conditions. In the projects that are brought forward with the help of the surface water system drainage coursework. The following case studies present projects which are both completed and uncompleted, and discuss delays during the design and construction phases and incomplete documentation of material delivery. Available data on the structure materials, maintenance and effectiveness of drainage system against water damage is required. Other than that, uh, care should be taken to minimize problems during the construction process by having proper plans and timely execution of those plans. Regarding efficiency in the operation of drainage system, procurement of materials on time and establishment of regular schedules for maintenance are recommended. The result in all have pointed out the need to incorporate appropriate drainage solution into the building procedure so as not to destroy the infrastructure and environment through water-related problems.